Okay, so we're going to start by creating the grids. So this is grid number 1, and that's grid number 2. And here I'm going to copy this 20 feet and 20. And I want this to be B and C. Okay, so that's the same. And we're going to start from the foundations, and then we will create like a structure with columns, beams, and a roof. Foundations are always the same. If we have a basement, we always need a concrete retaining wall, and then we need wall foundations for the walls, and then we need isolated foundations for the columns. Okay, so it's if we are working with basements, basement it's always made of concrete, so we don't make a basement with wood. It doesn't make any sense. So let me see the elevations, and let's analyze the levels. Okay, so we have a level 0 here, so this is level -9, so that will be the basement. Okay, in this case, I'm going to do something because the wood, it's a wonderful material. It's sustainable, it's renewable, because we plant more trees, and by the way, there are more trees now in New England than 100 or 200 years ago, because they were cutting off a lot of trees to burn the wood to create energy for the industry. But now the industry is not here anymore. Everything is in other countries, and now they are not cutting off as many trees as they did 100 years ago. Okay, so using wood, it's a perfect choice because it has a lot of advantages. Wood has absorbed a lot of CO2 during its life, so it was what we call carbon sequestration. So that concept is what is carbon sequestration? Is the process of storing carbon dioxide in underground geologic formations. Well, it can be geologic formations, or it can be in wood. Okay, so that means that if we are generating CO2 as a human activity, trees absorb part of this CO2. So if we use that tree to build something, to create a building, it has absorbed a lot of CO2 during its life, and we don't release again that CO2. Okay, so if we burn the wood, then all this CO2 it's released again to the atmosphere. But if we don't burn it and we use it as a structural element, all this CO2 that the wood has absorbed doesn't go back to the atmosphere unless there is a fire in the building. Okay, so that's why wood, it's a great material because it's renewable. It absorbs a lot of CO2 and doesn't release it, because to manufacture steel or concrete or even glass, we need a lot of energy, and energy nowadays, 80% of the energy, it's created by burning fossil fuels. So if we want to create a ton of steel, we have to release a lot of greenhouse gases, but to create a ton of wood, well, we only have to do this process of laminating the wood, but we don't release a lot of CO2. Okay, so in terms of environmental friendly material, wood, it's the best. Okay, and but it has a drawback. Wood cannot be in contact with the soil. Okay, because there are bugs that literally eat wood. Okay, so if we insert a wooden element in the soil, it's very likely that there will be bugs eating that wood and affecting the structure of that wood. So we always have to separate the wood from the soil. So this is what we are going to do today. Okay, so imagine that we have a wall, a concrete wall from level -9 to level 0, and then I'm going to create another level, level 1, no, level, let's say 3 feet up. So I'm going to name this level 3. And I don't want this level 7, so level 10. Let's call this level 15. And finally, level 30. And this can be level 45. Okay, so we're going to create, that's the basement, and I have a gap between level 0 and level 3. I will explain you why. And then we have 15 feet from, each level will be 15 feet. So we will have a basement, and then first, second, and the third floor, and on level 45, we are going to have the roof. Get rid of this. I thought I had deleted this, but if you have these reference planes, get rid of them. And even this one, because we just want the grids. I don't know why it wasn't here. Okay, so we just want the grids and the levels. Good. So first, if we are on level, it doesn't show up here, level -9. I don't know if it shows up in your project browser. If it doesn't, you have to go to View, Plan Views, Floor Plans, and then here we have levels that don't show up there. So let's select it and do this. Okay. And level -9, it's not there. Good. Okay, so let's open level 3. No, level 0, it's okay. So on level 0, we have to create a structure wall. So let's select the retaining concrete wall, this one. And we have to go from the base constraint, make it level -9, up to level 0. And the base offset type 0 here. And we are going to, so imagine that this is a corner as we did for the concrete project. So this is the corner, and that wall goes from level -9 to level 0. There you go. Okay. And this element will have a wall's foundation. So select the wall. And here we have the wall foundation. If we need some structure in the basement, I will make it a concrete structure. So I have to select columns, structure, columns. We have, okay, so you see that here we have this glue lam. This is laminated glue or glued laminated timber or wood. Okay, so this is, we have wooden columns. We have concrete square columns. We have concrete round columns, and these W shapes. Okay, so here we have everything. We have the steel, we have the concrete, and we have some wooden. So let's select this concrete square column, 12 by 12, and we are going to place it here. Okay, so remember that this is the corner of the building. On this, where is it? Okay, so they are in the right position. And now we need isolated footings. So the isolated footings, they have to be on level -9. So I have to place the footing here. here, here, and there. I don't see them because they are on level 9. And what else? Remember that we always need beams. I can, if I don't see level 9, I can go to view range. And in view range, the bottom, it's associated with level 0. I can do it associated with level 9. The bottom and the view depth. And now we can see the footings there. Okay, what's next? We need beams. So there should be, I have these elements here, okay, so made of laminated wood, but so far I want this concrete rectangular beam. So this one, and then I always connect. Oh. They have to be on level edit work plane, because I want this to be on level -9. There you go. And now you see that this beam, it's thicker than the footing. So we either change the footing or we change the beam, because this is not very nice. So let's change this. What is the footing width? Apparently it's 1 foot and 6 inches. Okay, so we have to make this 1 foot and 6 inches. If we edit type, yeah, so the H, it's 2 feet. It has to be 1 foot and 6 inches. Now I want to edit work plane. It has to be level 9. So why is it -9? Let's align this and that. Is it working well? Yes. Okay, so that's the, it has to be lined up here at the top. And usually the beams connecting footings are either smaller than the footing, or at least the same size as the footing. There's a problem here. So in this case, I'm going to select the footing and I'm going to edit type, and I want the foundation thickness. I want this to be 1 foot and 6 inches. Okay, so now everything works well here. And now I can copy that beam here, and I have to connect structure beams. I don't know the reference level. I want to be -9, and I want to connect this one and that one. And let's see if we have done this. Okay, edit work plane, -9. There you go. Okay, so here we have the basement. The basement, it's always the same. Then we will need like a concrete slab on the basement. So on level 0, I can go to floor. I can go to this generic floor. Okay, so here we have wood joists, and probably we'll use this, but not for the basement floor, because we cannot do something made of wood in contact with the soil. So let's select the generic floor, edit type, select concrete here. Cast in place. And then the thickness, 1 foot. 1 foot is enough. Okay, and now a rectangle is attach. I think I did something wrong. Yes. Okay, I can use this here, but I need another one on level -10, so I can copy this one to level -10. Okay, so I have the floor, the beams, and the footings. And this is the first floor. Okay, so this is the basement, and this is the first floor. Okay, so yep. Can you what the floor? Well, when I did it for the first time, I wanted to create it on level -9. Okay, so I'm going to do it that way. So it's floor. Select well this generic, but now by editing type, I have to make sure that this is made of foot. Okay, and now by default, I don't know why, but here we have level 30. You know, sometimes Revit goes crazy, so I'm going to set the work plane on level -9. Okay, so if I set the work plane on level -9, I can go. I can create this rectangle. And click OK. And now on the 3D view, it's in the right place. Okay. And now if I want another floor, look at what I did here. Okay, if I select the floor here, filter, and I select just the floor. In this case, my floor starts inside the wall. Okay, so this is how what usually happens. I create a footing, then the wall, and then I create the floor. But on the first floor, this is the basement. On the first floor, the floor has to be at the top of the wall. So I need another profile. Okay, so I'm going to do it differently now. But what I want you to understand is that for this floor, the perimeter is the internal face of the wall. But in the first floor, the perimeter is going to be the external face of the floor. So if I'm on level 0, and I want to create a floor here, the same one, structure floor. Well, I selected this generic floor, and I think it's concrete and 1 foot. Okay, so this is it. I should have renamed it, but anyway. So now this rectangle, I want it to be this corner, the external face of the concrete wall. And I can go up to the, well, I can go up to this, the midpoint of this one. And now if I attach things, okay, there you go. Okay, so that floor is, the perimeter of the floor is the internal face of the concrete wall in the basement. the perimeter of the first floor, it's the external face of the wall. Okay, so what about now? Imagine that we want to, okay, actually, this is what I'm going to do now. To stop recording. If I'm on this east elevation, I want this wood to be up to level 3. So all these walls, sorry, the top constraint is level 3. Level 3. Okay. I might have this issue because I did this with the columns. Okay, I'm going to do the same with the column. So let's move the constraint up to level 3. And even with this one. And why it doesn't work with the walls? Because I attached the wall to this slab. Okay, so I'm going to do it again. I want this wall to be up to level 3. And now I want to create on level 0, I want to create another floor, structural floor. And the rectangle, now it's going to be in the interior face of the wall, not the exterior. Because otherwise I will attach the wall to the floor. And I don't want this. Okay, so I want the floor here. And then this extra 3 feet of concrete. Okay, so remember that here, no, not here, here, you have to create all that stuff. Okay, what we did before. So if this is the soil level, level 0, I want to start with the structure like 3 feet above the floor level. I think it will be enough. Okay, so now let's insert the wood element. Let me see what we have here. We have columns, and we have this glue southern pine column. Okay, so it's made of laminated timber with glue, so that's why we have this glue LAM. Stands for glue and laminated. And here we have 8.5 and 11 and 12 by 12. Okay, so let's select the 12 by 12, 1 foot by 1 foot. And then we're going to place it just at the top of this. Here. And here. And see what we are doing. Okay, great. So you see that the column is there because we start on level -9. No, I want to start on level 3, and I want to go up to level 15. There you go. The same thing here. Start on level 3 and go up to level 15. If we use shaded colors, we see that there are 2 different materials. We have the concrete, and here we have the wood. Okay, so that would be good enough. So I can go to level 0, and I can copy all these wooden elements. So I will copy this one here. So let's see what I'm doing. Okay, so I want the same on this concrete wall here. So I'm going to copy this one. here and here, and this one here. And now I want to copy these three columns, 1, 2, and 3. Copy here. Nope. I want to copy 1, 2, and 3 from this grid to this grid. Okay, now it works. Okay, so the soil level will be here, like 3 feet below the wall, and then I start this. So that would be good enough, okay? But we can do even better. So we're creating something even better than this. And what is it? I want the connection. So one of the elements that I downloaded, it's this, we have this opening. Okay, so you have to download these 3 elements. If you open it, you have to upgrade the model because they are made in Revit 218. And this is not the one that I want to upload. I want to open, I think this is the knife plate bracket. Yep. This one. Okay, so what is this? This is a steel element. It's bolted to something, and then here we insert the wooden element. I think there was a detail when I was showing you this. Okay, so it's something like that. You see that we have like this steel element, and that steel element is inside the laminated glue, and then we have bolts here. Okay? So that's what we are going to do now. We're going to insert this element. We're going to rest this on the concrete wall, on the concrete column, and then I'm going to start the wood as of this point. Let's do it, and I think it's easier doing it than explaining. Well, first, this one, you have to, if you're by default, you open this family and it's in create. But if you go to insert, you have to load into the project. So you can load into what project? The wood template. Well, it was already there, but if it's not, we have to insert that. And then where can we find those elements that we have inserted? It's in architecture, component, place a component. And here you see that we have, well, I have already inserted this parametric bucket hanger. That's to connect a beam in the column. But this one, the knife plate bracket, is to connect a column to a concrete wall or a concrete column. So let's click here. And well, I'm going to insert it. You have to insert it at the top of the wall, not here. Okay, so here it doesn't make any sense. It has to be there. So I'm going to insert it here. It's not the right place, but this is it. You see, so this is bolted to the concrete wall. And then we have this gap, and then the wooden column goes like a few inches above this. So let's go to the north elevation. And in the north elevation, I see that guy here. So I have to move it from this midpoint to this axis. There you go. Well, this is not exactly, this is not perfect. I think we need another level right here. Okay, so that level, it's 3 and 8 inches. I'm going to change the scale to 1/4 because I have 2 levels here very close to each other. Okay, but now this is level 3 and 8 inches because the height of this element it's 8 inches. So this column has to go from level 3, 8 inches to level 15. There you go. Okay, so that's the perfect, it's high level. Okay, so well, nobody does. But that's the right way to do it, okay? Because we cannot press wood on concrete directly. We need this transition. It can be this one. I have found this, but there are other solutions. So, but there's something to connect the wood to the concrete. So we need a steel element in the middle of these two materials. Okay. And this is how it works when we're working with these kind of structures. First, we need to prevent the wood to be in contact with the water, with the outdoor water, and especially with the soil. And then connecting the wood to the concrete, we always need something, we only a steel element just in the middle between the concrete and the wood element. Okay. So now we should do the same with all these columns. I'm going to select all the columns. I'm going to change the base level to 3.8. Yes. I'll do it again. Okay. So I'll start from scratch. But the first thing we have to do, now that we know that this is 8 inches, we have to create this gap. So all these columns have to start on the level 3 feet and 8 inches. Okay. Now, architecture component, not model in place. It's place a component. Okay. So when we insert or when we load a family into this project, it's in this weird place. It's in place a component. And here we have to select the parametric knife plate bracket. You have this element on your, okay. So you select this one. And now you have to place it, not the bucket, the knife. This one. Okay, so you have to place it at the top of the wall. And you see that if it's centered, you will have this dashed line highlighted, okay? And now we have to go to the north elevation and we have to move this up to this axis from the midpoint here. And if this column is 8 inches above this level, it will work well, like this. You get it? You will find out that in good buildings made of wood, we always have this kind of connection. Sometimes we don't see it because we can have a flooring and we can hide this option. Okay. But I think it will be there. Okay, so the transition between the column made of wood and the slab or the wall or columns, it's always a metallic element like this. Okay, so now we have columns and we have beams. Okay, so that's always the same in concrete, steel, wood. We have vertical structural elements, horizontal structural elements. So on level, what level is this? Level 15. So I'm going to open level 15 now. So on level 15, I can create columns connecting create beams, sorry, connecting columns. So I go to structure, I have beams, and there should be a glue. Okay, so we have this glue laminated southern pine. And we have this glue laminated beam with integrated bucket. Okay, let's try the first option, and then we will try the second one, because we'll go step by step. So if this was 12 by 12, we can select the 12 by 16. Why 12 by 16? Well, beams work much better if this is 12 and this is 16, and then we have to scan this way. Okay, so this is basic structure. We don't have to calculate anything, but if we find a beam like this, that's the way in which we place the beam. It's not the other way around. Okay. So the maximum dimension, it's always the height, not the width. Why? Because a beam, when the beam is resting into columns, the formation of the beam is going to be like this. Okay, so we need the maximum amount of material at this section. And where do we have? It's the moment of inertia, but it has to be this way. Okay, so it's a terrible mistake if we have a beam and we place it in this direction. It can happen. The building won't collapse. Don't worry. But it's like, okay, you don't know anything about structure. It has to happen. Okay, so it's beams. The 12, it's the width, and the 16 inches, it's the height of the beam. So let's select this 12 by 16, and let's connect two columns, just two columns, and let's see what we have done. Okay, that's it. Okay, perfect. So is that enough? Yeah. So if we are not aiming at something very high level detail, so that would be enough. We have timber columns and beams. Good. So we can keep doing this on level 15. So I can do this here. What happens if I connect the beam all the way like this? What happens? Okay, so this is here I have two beams, and here I have just one. I don't think it's an issue. Okay, so let's do it, and if we have to change it, we'll change it. So we are going to create more beams in this direction. And now I'm going to copy this beam here. And I want to copy these two beams there. Okay, we always have to create a frame with columns and beams. So that would be more than enough. But what if we want to make it better? So this connection, again, if we have a connection between two elements, we need this steel element that it's bolted to one of the elements, and then it's bolted to another element. So what kind of element do we need to connect the beam to a column? or to connect two beams. But here we are connecting this beam and that beam. And then there's a column here. Well, so that's why we have this bucket element. So this bucket element is something that it's bolted to that beam here. And then at the same time, we create like a bucket. Okay, so it's an element that it's a U. And then on that U, we rest the beam. Okay, so we have an element that is the elevation is something like this. We have a U, and we have these two plates. And we bolt this to the beam, and then we rest the beam on this U shape. Okay, so that's what we are doing. And then we bolt this to the perpendicular beam. Let's see how it works in Revit. So we go to architecture, component, place a component, and here we have this knife, whatever. This is for columns, and this is for beams, the bucket hanger. So let's click here, and now we have to place it. I'm going to place it right here. Again, we don't place this element at the top of the beam. It has to be here. Okay. So I'm going to place it here. And look at this, how it works. Okay, so we all understand that this beam has to be here. So I'm going to go to the top view. And then I'm going to move it to the midpoint of this one. Okay, so it has to be here. What's the problem? We don't have the right size. Okay, so first is this bucket or this element is too narrow and too deep. Okay, so I either change this or change the beam. What is the easiest way? If I edit type here, well, I can change all these dimensions. I think it's quite complicated. So we either, there are different dimensions for these buckets. So I have uploaded just one. So what I'm going to do is to change the beam accordingly because it's easier. So on level 15, I need to know where I am. I don't know. Okay, here. So what's the width of this element? I'm going to annotate. So the width is 8.5 inches. Okay, so now this beam, I can edit type, I can duplicate, and this is 8.5 or 8.5. So did it change? No, it didn't. Edit type. Oh, because I changed the name, but I didn't change. Okay, so I have to change the dimension. This is, it's not 1 foot, it's 0 and 8.5. Okay, so now the width is perfect. And now I have to change the height. So the height of that beam should be, what is the, how can I measure the height? In this north elevation, okay, I have it here. So I annotate. Okay, so it's 1 foot and 4.5 inches. So I select this beam, I edit type, and this is 1 foot and 4.5 inches. Okay, so now I have to line up the beam. I select this, align, this one, that one, and now it works. Now it's perfect. Okay, what I should do now is to change all the beams to the same type. So that beam is the 8.5. There you go. What? Oh, that's interesting. Okay. I'm going to change. I think I need another typology because this has to be 1/16. It's a 4. There you go. Okay, yeah, with this we have to be careful because this beam has to be 12/16 and this beam has to be 8.5/16. Everything would be easier if I had found a bucket with 12/16. We don't have to change anything, but anyway, this is the only one I have, so I have to adjust all these elements there. Okay, yeah, because this beam has to be connected to the column, and but this beam can be this way. Okay, so we will have bolts here, we will have bolts there, and now this is the right connection between the beam and between two beams. This is too complicated. Is there a way to make it easier? Yes, there is. So I'm going to delete everything. And I'm going to do it again with the other family that I found. But now we have to go to structure and we have to go to beam directly. And then on these beams, we have this glue laminated beam with integrated bucket bracket. And what the hell is that? So if I click here and I just go to level 15 and I create a beam from this point to that point. Okay, so here I have a beam that has this element in both sides of the, and it's 8, well, yeah, it has this dimension. Okay, so again, I have just downloaded one of the families with this dimension, so it doesn't go very well here. So what would I do? I think I'll try the 8.5/16, and I'll try it this way. Okay. No, sorry, this is a 12/16. There you go. And then I'll try that beam from, so I can copy this one. Like this. And now between these two, I'll try the other one. The one with the integrated bucket brackets. There you go. Okay, so that looks perfect. But I need to find a connection between this beam and this column. So it's a question of going to that website. I can give you the reference for that website because I did it yesterday in my office, but I don't have it here. And you can download different sizes and different connections for beams and columns with different sizes. But that's the way we have to do it. Okay, so the beam, the wooden beam, we always need this element, that steel element, to connect two different parts or two different elements of the structural of the building structure. Okay, so we need this for columns and concrete walls or concrete columns or footings or whatever, and then we need this to connect two different beams there. So let's do this very quickly, okay? So we're going to do this one. So from the number one is the double standing steam system. You see that this is zinc, so the last layer, it's always a zinc layer. And then we have 5 is the rafter zone. Okay, so this is resting on the rafters. So the first is the vapor control layer. The second, it's a panel, wooden panel. Then we have thermal insulation. This looks like expanded polystyrene. And then we have another wood. And then we have the number 2. Okay, so we have this. Let's do this. We have 1, 2, 3, and 4 layers. So it's very easy. On a 3D view, I'm going to get rid of all the levels that I don't need because I only need level 1. Okay, so that file is just for a detail. So I'm not, this is not a building. Okay, so we are working with level 1, and this is 0 inches. So here I have the first layer. So I'm going to create a component, model in place. And if this is a roof, let's create this as a roof. So and I'm going to create extrusion elements. So the first one is going to be just a square, let's say 26 by 26. No, it has to be something around 3 feet. Okay, 3 feet and 10 inches. And now what's the width? By default is 1 foot. I'm going to make it 1 inch. Okay, so that would be the first board. The second can be, so I'm going to go architecture component, model in place, and well, let's make it roof. And now I have to pick a plane. I have to set the work plane, but pick a plane because now I want to start my second layer on this layer here. Okay. And now I select extrusion, rectangle, the same thing. And this extrusion end, I want something very thin. Let's say 1/8 of an inch. Okay. So now I have two different layers. You see this one and that one. Now, if I need the thermal insulation, again, architecture component, model in place, roof, extrusion, and rectangle. Oh, first set the plane. So pick, and I want to pick that plane here. So now I can draw this rectangle. And I want this to be 1 foot, 12 inches. Okay, so we can have 12 inches, and that will be the thermal insulation. So you see that now we have 3 layers. The wood, this can be the vapor barrier, this can be the thermal insulation. And now we need another board. So for that board, we can create another architecture component, model in place, roof, and extrusion. Set the work plane, and I'm going to set the work plane here. So now another rectangle, and I want this to be 1 inch. There you go. And finally, I want another membrane like this one with 1/8. So finally, component, model in place, roof, pick plane. I'm going to pick this one, extrusion, rectangle. And this is 1/8. There you go. Okay, so as you can see, we have here different elements. In this case, we don't have the sink because it's more, well, that's going to be more complicated. So we will do that on Friday. But we have this, we have the first board, then the vapor barrier, then the thermal insulation, another board. This is the waterproof layer. And finally, we have the zinc. So that's the only layer that we don't have. But if we want to see different materials, now we can select this and we can drag so that in this okay, so here we can see like different layers with different with different materials. And now we only have to change the right material here. If we select this one, edit in place, and I select it again, here I can change the material. So this can be asphalt. Or damp roofing, yeah, something like that. This is the waterproof layer. So I have changed the material. This is wood. So I edit in place, I select this material again, and I change this material to plywood. And finish model. So when you use realistic textures or realistic materials, this is what we have, okay? So we have this waterproof layer, Then we have this wooden layer. So if we edit in place this one, that would be material insulation. Okay, so the insulation doesn't have a, well, it has this color, but little by little, we are doing the same thing we have here. So it looks like realistic, and it's quite easy. We only have to create like a rectangle, and we can add different layers, assigning different materials. And well, on Friday, we will finalize this because the goal will be to create a sheet of specifications with the 3D detail, the realistic 3D detail, then the section with names or with numbers, and then the legend and the specifications here. Okay. So for this project, we are going to create specifications like this, and then we're going to create the detail, the section with all the exposed elements here. So we will be working with this, well, today we started, Friday and next week. And by the end of this week, we will have to submit this house with all the specification sheets of all the materials that we are using.